snowstorm formed.
Tom Henderson seeds clouds for a living.
So Schaefer called the Nobel Prize winner over, Langmuir, and they looked in the box and they repeated it, and Langmuir said, Schaefer, there's the experiment that shows that man is someday can control the weather. And Schaefer said, really, you know? And so they got really excited about this. They did it again, and Vonnegut came in, and he looked at the experiment. And he reached over on the bookshelf and pulled off a volume there, and Langmuir said, what are you doing, Bertie? And he said, oh, I'm looking for a substance that has the same crystal structure as ice. You know, here their minds are going, just like this. So they got, he found one, and Vonnegut said, well, what is it? And Vonnegut says, something called silver iodide.
All right, when speaking of crystalline structure of dry ice, which is frozen carbon dioxide, a very similar structure is held by a different substance called silver iodide. All right, silver iodide.
Do we have any of that around here in the lab? And Langmuir said, I don't know, let's go look. So they went down and they found a little tiny bottle of silver iodide. They made another cloud in the cold box, took a little spatula and sprinkled some in there. Nothing happened. And just like that, Bernie Vonnegut said, the particles are too big. So, you know, here their minds are going again. And so, well, what do we do? So Vonnegut put some silver iodide in solution with acetone, and they made another cloud, and they swung some matches around in this acetone, dried them out, and then they made another cloud and struck one of these matches and put it down in there, and bang, another snowstorm. Just like that, you know, just like the dry ice. And see, the particles were too big. The way the guys really, their minds just crazy, you know. And that's how it really all started, actually, just from that little serendipitous experiment in July of 1946.
The current technology hasn't changed much from that initial experiment. The silver iodide is still burned to make the tiny particles, but instead of a match, something with a little more punch is required.
Ground generators are often used to send the silver iodide into the air, but over mountain terrain like the Sierra Nevada, airplanes make the best delivery system. The rest of the cloud seeding operation is like an Easter egg hunt, and sometimes the clouds are hard to find. First, meteorologists do their best to predict when the storms are going to be moving over their area. They also need to forecast if those clouds are going to be good cloud seeding candidates.
Unless clouds are about 5,000 feet minimum, feet thick from the base to the top, they don't usually have enough moisture in them to produce additional amounts from that particular cloud. So one of the parameters is cloud thickness.
As those clouds get closer, direct readings can be taken.
The tool we use is radar, actually, to identify storm characteristics or cloud characteristics.
When the airplane flies, it generally follows a predetermined path. After all, they want the additional water to fall in a specific area where they can get the maximum benefit. And when the time is right, the flares are lit and the silver iodide goes to work.
The silver iodide acts as a glaciating agent, which causes the water droplets to form the ice crystals that we've spoken about before. This begins the Bergeron process, which is in Chapter 2, and the water droplets start to attach themselves to the ice crystal, and it grows bigger and bigger, and then the other water droplets continue to attach themselves, and eventually what you get are snow falling down or rain falling down, and then that's how it works. Yeah.
Success or failure is hard to prove. Would Mother Nature have given the same amount of rain or snow had cloud seeding not happened?
And to reach in the cloud and pull out the information you need that shows that that's what you did and over here is what nature did is difficult. So it has to be done in sort of indirect ways. And pretty serious statistical evaluations are one way to do it. What those show is somewhere between 5 and 15% increases in stream flow as a result of the cloud seeding.
At the National Weather Service in Hanford, California, meteorologist Dan Gudgel says accurate data in this area is hard to come by.
And it's also hard to assess how effective the precipitation is because they couldn't get a rain gauge below the clouds. These estimates are all based on radar.
And some say if you squeeze moisture from a cloud, you're in effect stealing water from another area that would have gotten rain had you left it alone.
All right, robbing Peter, pay Paul, take 6. And action. Cool.
I suppose you could get into arguments whether if you're taking rainfall from an area that would get rainfall if you didn't have cloud seeding upstream, but that's hard to assess.
None of those have ever shown any decreases in precipitation downwind from these long-term projects at all. In fact, a few of those scientific studies have shown some very, very small increases as much as 100 miles away. We don't know why that is.
It's funny that Tom's livelihood comes from cloud seeding. In the beginning, he didn't believe it would work at all.
My background was originally hydrology. I was a senior hydrologist for a hydroelectric power company over in the eastern side of the Sierra, and the president of the power company saw a news release from GE Research describing what they had found by Schaefer's experiment. And the president of the power company got a hold of me and said, if you think this works, we ought to try it. And I said, oh, that's a bunch of hooey.
As it turns out, in the years following those first experiments, it was discovered that cloud seeding did more than just enhance the rainfall. There were some added benefits. Fog can be dissipated using the same techniques. However, if the fog is a warm fog, the process won't work.
All right, remember that a warm cloud, sorry about that, a warm cloud is a cloud, or it could be a fog with temperatures above freezing, 0 degrees centigrade or Celsius or 32 degrees Fahrenheit. A cold cloud, on the other hand, is a cloud or a fog with temperatures below the freezing level.
Hail causes millions of dollars in damage to homes and to crops each year, but cloud seeding has been shown to help dissipate hail. There have also been 5 documented incidents where an active tornado was seeded. In all 5 cases, the tornado disappeared within 15 minutes.
But that doesn't mean much. On average, a tornado only lasts 15 or 20 minutes anyway, and it's a good thing cloud seeders don't want to be accused of doing more harm than good.
The Rapid City flood of 1972 was initially blamed on cloud seeders. It was later found out that although there was a long-term cloud seeding project going on in the area, the day of the flood, no clouds were seeded.
There's never been a flood in the history of cloud seeding that was caused by the cloud seeding. There have been some public perceptions that because there was a flood and because seeding was going on in maybe nearby areas, they reached out and grabbed cloud seeding as the culprit.
There used to be a group in the United States that was opposed to cloud seeding, called appropriately enough, Citizens Against Cloud Seeding. Well, their agenda never really caught on. Today, there are dozens of companies across the United States that have turned the science of cloud seeding into a profitable business.
One such company is Atmospherics Incorporated, based in Fresno, California. They do most of their work in the nearby Sierra Nevada, trying to increase winter snowpack. But even with that, owner Tom Henderson, whom we've already met, has no shortage of customers.
Water districts, municipalities, hydroelectric power companies, those kinds of people. For example, here in the Sierra and in the Valley, groups like the Kings River Conservation District, the North Kern Water Storage District, Southern California Edison Company, Monterey County, and so forth.
You may find it hard to believe that man has been modifying the weather for years and never knew it. Consider the greenhouse effect.